Assalamualaikum and good afternoon to the audience and to the guest speaker. My name is Dr. Husni Harun from Faculty of Engineering and Built Environment, Masa University. Okay, I will be your moderator today. So we have with us our guest speaker, TS Dr. Muhammad Shohanas Zanar Azlat. And his topic today is brain-machine interface. Before he start with his topic, I would like to introduce to the audience who is Dr. Muhammad Shohanas bin Zanar Azlan. Muhammad Shohanas bin Zanar Azlan obtained his Bachelor of Engineering in Mechatronics from Allen University of Applied Sciences in Germany. And then he continued his Master in Master of Science in Electronic Engineering from Lathrop University, Australia. And then he pursued his PhD in University Malaysia Perlis, of course in Malaysia. And his PhD work was on feature selection for the enhancements of motor imagery classification using EEG signals. He is currently a senior lecturer at the Mechatronic Engineering Program in the Faculty of Electrical Engineering Technology, University Malaysia Perlis. His special field of interest include EEG signals, brain-machine interface, ground penetrating radars, neural networks, and machine learning. So without further ado, I will give this session to Dr. Muhammad Shohanas to present his webinar for today. Dr. Muhammad Shohanas, you can start now.
Okay, thank you very much to moderator, Dr. Muhammad Husni Harun. And first of all, thank you very much to Masa University for giving me opportunity in order to maybe it's not present, but to share my experience on research on brain-machine interface. Okay. So if you can see the slide. So nowadays, we have talked about, many of us have talked about AI, a supercomputer, and machine learning. So from this, the idea is come up from here, where we can also interpret our brain signal, because we have now a supercomputer, a fast computer, in order to process the data, the big data. So due to this, then we can have a interface on how we can interpret our brain signal and come up with the output in order to control such a device and etc. Okay. So basically today, I just want to talk or share about what is brain-machine interface, and I will also share one of the case study that we have doing here in UNIMED. So first of all, I introduce again myself. I'm Muhammad Shohanas bin Zanar Azlan. I'm currently a senior lecturer in University Malaysia Perlis under a mechatronic engineering program, and mechatronic engineering program is under Faculty of Electrical Technology, Electrical Engineering Technologies. Okay. So this is the high outline for today's sharing session. So first, I would like to introduce what is about the brain-machine interface, and then we will see how is the trend in brain-machine interface research, and also the market demand of the brain-machine interface, and we can see how's the future look like on this research. And then I would like to share one of the case study that we have done, which is one of the study that we have done is we want to classify a brain signal by using the imagination of the person or the subject, and then we can classify it using the machine learning algorithm. And then lastly, I just want to share or to show you we have also a research group on this matter on the brain machine interface in our faculty. Okay. So what is actually a brain machine interface, or we can call it a BMI? Actually, BMI is the interface where we can interpret the signal from our brain, from the human brain, and then by interpret it, we can convert it and come up with a command where that command signal we can use it in order to control devices such as a cursor, a keyboard, and etc. Actually, what actually occurred in the interface is the brain signal is actually being processed, where we have a step of in order to process, extract the features, and then classify it using a machine learning algorithm until we come up with a certain special signal or special output signal. And that special output signal, we can use it in order to operate a device or give a feedback to the subject. For example, if we want to control a device, to control a cursor, left or right, we can use the output signal from the interface. Or another example is in the rehabilitation process, we also can use that output signal in order to apply in a rehab process of the patient. So if you can see in a picture here, where when we acute the brain signal from our brain, so in the interface, actually what happened is we process the signal first by remove the noise, because the brain signal actually is have a many noise. It has a low signal to noise ratio. And then when we have removed all the noise, then we can extract the features. From these features, then we can use the features in order to classify the task by using the machine learning algorithm. As we know, human brain actually consists of different part of brain, namely such as frontal lobe, parietal lobe, temporal lobe, occipital lobe, and then we have also a cerebellum behind our brain. And each of these lobes actually have their own function. For example, if we say that the frontal lobe, actually it is consists of in our, for example, in our reasoning or problem solving, or or also in a motor function, such as when we want to move our hand or our feet. Actually, the signal is come from the motor function from the this part of the brain. We call it a frontal lobe. For example, also if we the signal want to make a speech or want to memorize something, so the signal is actually come from the lobe. We call it a temporal lobe. So in our brain, this is very complicated, and we can divide into the lobe, and each lobe have its own function. So actually, we can acquire the signal, the brain signal, by using in many methods. But the three main methods that we can acquire a brain signal is either we call it an invasive method, or partially invasive method, and also non-invasive method. Invasive method is actually we need to have some implant electrode in our brain. So this must be go through the operation and etc. Same goes also with the partially invasive BCI. The electrode on the brain surface also been put also through the operation. So one of the method that is a famous method because it's not involve any operation on our brain or on our head, we, is a non-invasive method. Where by using non-invasive method also we can acquire a brain signal, which is by using the EEG device, where EEG is stand for encephalogram device. So EEG have many type of EEG in the market. We have a 14 channel EEG. That means we have 14 electrode that we can put on our head, and then we can acquire the signal. Or we also have maybe a 24 channel. That means we have 24 electrode. And some of the EEG device also have a 64 EEG electrode where we can acquire a signal from 64 point on our brain. If we want to see about the BCI market demand and trend, this is what we can see, which is the period from 2018 and is spreading until 2026. We can see that the market for the brain-computer interface is actually in a increased way. So if you can see here, they predict by year 2026, the market will be increased by 12%. So based on year 2020, the fastest growing market on this BCI, for example, the device on how we acquire the brain signal and etc., actually is the growing faster growing in the Asia Pacific. So by seeing this market demand and trend in BCI, so we can say that actually the BCI research have the good future for the if we want to study and make some investigation on the BCI brain or BMI brain machine interface. And if we see when we go to an academic area, so if we see in the peer review BCI article, we also can see that the research on BCI also in a trend of increase. So this is a source from Shi et al. 2012. We see that the research work related to BCI were growing with the extremely rapid rate starting from year 2000 onwards. So research on BMI using electroencephalography, which we call it an EEG, has been explored by many researchers in recent years. So there is still a lot of opportunity in order to improve or in order to see or to find what another topic that we can tackle in order to improve into this topic of the research. So EEG signal processing is one of the topic for BCI, where we can the researcher always come out how we can improve the classification rate on to classify the brain signal, so we can improve it maybe until 100%. So actually it is a very challenging task in terms of the performance and the efficiency. So this evening I just want to share one of the project that we have done in our research group, where it is about how we want to classify a task based on the brain signal using the machine learning algorithm. The task is actually we have asked the subject or the person to imagine some movement of the hands. So during the person imaging the movement of the hand, then we acquired the brain signal, and then the brain signal that we have get from the person, then we process and we classify it using the machine learning algorithm. And then when we see the accuracy of classification, we can have the good result on it. So actually, again, what is brain-machine interface? Actually, brain-machine interface is a link between a brain and external human intention, where it's not depend on the brain normal output pathway. Actually, it is an alternative way to control external device for paralyzed patient. We can apply on paralyzed patient, cerebral palsy patient, lock-in syndrome patient. One of the method to induce a brain signal, if we want to make or want to study on a brain machine or want to acquire a brain signal, one of the method to induce a brain signal is by ask the person to imagine something. So in this study, we have asked a person to imaging moving the hand, and during the imaging process, then we acquire the brain signal. The thing that we say imaging something, if we see in a brain machine interface a research area, we call it as a motor imagery, whereby motor imagery is actually when we imaging something, the movement of the, for example, our hand. And then when we imaging, then during the imaging, actually the our brain is induced something, and then from this it come out with the signal. So that signal we will acquire, we acquire using the EEG device, where we use the EEG device, and then we process the signal, and then we come up with the classification rate using the machine learning algorithm. So that's signal actually can be used in order to apply on any device in order to control, such as a prosthetic arm and etc., or the wheelchair. So what is actually motor imagery? Actually, it's a mental process on how we imagine something. By imaging something, and then actually it will simulate the action in our mind, same as like if we want to move our hand. Before we move our hand, actually the brain is simulate something in our mind. So that is the process, we call it a motor imagery, where actually we not perform the actual movement of the hand movement, but we only imagine the movement only. And by imagine the movement, then the brain can induce a data of signal, and then we can process the signal and classify it. Actually, the research on BMI is still going some issue, especially when we want to develop the BMI, the framework. And focus should be given to the key factors that play important role in the framework for development of a BMI system in order to enhance its performance, classification rate, and efficiency. So in this study, we want to concentrate on issue regarding how we can improve the accuracy rate or classify rate of the motor imagery by introduce two things. One is we come up with the experiment protocol on how we can acquire the brain signal. And then the second is how we can choose or how we can reduce the data by reduce or by remove some of the electrode that we need to use in when we acquire the signal. Because by remove some of the electrode that is not significant to the motor imagery, actually we can reduce the computation time our process computation time. So in this objective of this study objective, first we want to design a experiment protocol. This is the goal of this study. And then we want to develop a framework for BMI system in order to recognize the hand movement from a brain signal by stimulate by the motor imagery or by imagination of the movement. And then we want to improve the accuracy classification rate by develop a new EEG channel or EEG channel reduction methods. And then how we want to see either the method is okay or not, we validate it by using a machine learning algorithm or the neural networks. Actually, in previous work, there is a lot of EEG channel method that have been introduced by previous researcher, and the channel reduction or channel selection method actually can be divided into three methods: filter method, wrapper method, and embedded method. So in this study, we have choose the filter wrapper method in order to reduce the EEG signal. So actually, by eliminate or remove the channel by using a channel selection method, actually we can reduce the setup time, because when we want to take a data using an EEG, we need to set up carefully how we can put the scalp of the EEG on the head in order to get the good signal. So by knowing the channel that very significant, then actually we can reduce the setup time, and also by remove the channel that is not significant, we also can minimize the time for computation time due to the present or less number of channel. So the experiment protocol, actually we have a start, and we take the data from 10 subjects, 10 healthy men is participate in this study, and the age of the subject is in the range between 22 years old to 34 years old. And actually, we have done this experiment, this study in University Malaysia Perlis. So most of the subject is come from University Malaysia Perlis, and the subject must be free medication and alcohol free in order to get the good signal. And before the experiment, we have advised the person to have enough sleep. So when the person has enough sleep, then during the experiment, then the subject can concentrate during the experiment and can get a good data. Before the experiment, each subject is briefed verbally and practically about the procedure, and all the subject has signed the consent form for the ethical approval. Okay. So this is the experiment protocol that we have come out. How we induce the brain signal, the motor imagery brain signal, is by using the video demonstration of hand movement. So before we ask the subject to imagine the hand movement, first we play first the video demonstration on hand movement in front of her or he, and then we have asked the subject to relax, and then after that, then we start to record the signal. Before it, we ask the subject to imagine the task, and then we start to record the signal. And all this experiment we have take 10 times. So we need to see because one trial of experiment is not enough. So we have take 10 times of data. So the subject need to imagine on movement for each task and then relax and then again imagine. So during that we acquire the EEG signal from the subject. So actually, this experiment is no potential risk because it is a non-invasive methods, and also the ethical approval is already obtained from University Malaysia Perlis. So what actually the subject watch of the video demonstration is about a person on showing the movement of the arm for each task. Actually, how many tasks? Actually, the task that the subject need to imagine, we have four, which is include the relax tasks. Okay. So first, we have asked the subject to relax. Then we take the EEG data. So relax means during this task, the subject will be in a state of rest. The subject do not perform any task. And also, we have also asked the subject to not to think of anything during we take the data. And then the second task is we ask the subject. First, we show the video demonstration on right arm movement, and then we ask the subject to imaging move their right arm. So during this, we start to collect or acquire the EEG signal. So we ask about 10 seconds in order to imagine it, and during this we take the data. There is also we have asked another two tasks, which is we demonstrate the video first. The video demonstration moving the left arm, and then we take the data, and then moving the both arm demonstration video moving the both arm movement, and then we ask the subject to imagine he's moving the both arm, and then we take the EEG signal. So we ask the subject not to move his hand, just imagine the movement only. And then in order to improve the accuracy of the classification of the motor imagery, we also have proposed a channel selection method. So as I said before, it is based on the wrapper method, where we obtain a subset channel by rank the channel value based on the standard deviation of the raw energy signal. So why we use the raw energy signal? Because it is easy to compute, and actually energy can show either the channel is active or not, or less active, or very active. In other words, channel with low energy is interpreted as a channel that contain high noise. So that's why we use the energy of the raw signal. Based on that, then we rank the channel. And also we use the standard deviation to see the dispersion of the measure data. And then this is the algorithm of our channel selection. So by rank the channel, and then we find the accuracy of the classification, and then based on that, then we can have the channel subset that give the highest classification accuracy. So the channel subset that give the highest classification accuracy will be our selected channel. During the process of signal processing, also we need to extract features from the signal. So we have used two algorithm. We call it a spectral-based features algorithm and fractal-based feature algorithm. Why we use these two? Because first, for the spectral, the pattern for signal spectrum of movement imagery is actually similar to actual movement signal. And for fractal, actually, uh, EEG signal actually is the low, have a very high low to noise ratio, and it is a non-stationary signal. So due to the non-stationary signal and self-simulatory behavior of the EEG signal, then we have used the fractal value in order to extract the features from the signal. And then how we classify it, we used a normal neural network, feed-forward, element, and radial basis, where it can give a good generalization abilities and can work well on non-stationary stationary signal. So this is our finding on accuracy. That mean the accuracy mean that how good is the model can differentiate between the four tasks based on using the brain signal, the relax, move left hand, move right hand, and move both hand. So if you can see here, the proposed model can achieve overall up to 98% of accuracy. That means the model can differentiate the task until up to 98% correctly. And if you can see here, actually the fractal features can give a good performance than the spectral features. And this is when we divide it based on the each of the tasks. And as we can see, all tasks can be classified more than 95%. Just we can see the lowest is the lowest recognition rate is when the person imagine the both hand movement. And of course, if we can see that the higher recognition rate is relax, because relax also actually is induce the significant brain signal when we are in a relaxed condition. But overall, if you can see for each of the tasks, actually it can correctly classify more than 95%. And the finding on the channel reduction, from the algorithm, we can see that after we can compare when we using all channel and when we using the channel that we have select. As you can see, we can reduce the computation time between 7% to 35%. That means because we take the data from 10 subjects, so it depends on the subject itself. So some subject, the result we can reduce 7%, some can reduce up to 35%. Because when we work on the brain signal, so that means each of the person have a different brain signal, because our brain have a different characteristic. So that's why we have a different result depend on the subject. But overall, we can reduce the competition time, and also by reducing the number of channel that we use from 19 channel, or then we can reduce between 5% to 26%. And by also we can compare when we see about how what channel that we have uh, select based on the brain lobe, our brain lobe. Actually, when we compare it, we see that most channel that covers the frontal lobe and parietal lobe are selected by the subject. So that means the channel electrode that placed at the frontal lobe and parietal lobe is the most selected. Compare the electrode that placed in the occipital lobe and temporal lobe. So when we see this, we can make a conclusion that this is right because actually when we imaging is uh, actually come from the frontal lobe and parietal lobe. So that's why most of the channel is selected is actually located in this area compared to the channel that is in temporal lobe and occipital lobe. So the conclusion that we can make, we have can come up with the experiment protocol on how we can acquire a brain signal, and then we propose the suitable method or suitable feature extraction algorithm in order to extract the features from the signal that can give a good result or good accuracy result when we classify it. And then based on the channel selection method also, we can select the significant channel that related to motor imagery, as I show you just now, which is in the area of parietal lobe and parietal lobe. So most of the channel is located in that lobe. So that means that is proof that this channel selection method is same as the theory where the motor imagery signal is mostly come from that area. And also based on that, we also can reduce the competition time in average of 22%. And lastly, by using the machine learning algorithm, we can classify the data based on the features data set using a spectral energy and also fractal features by getting the accuracy more than 90%. So actually, we can work in the future work. We can propose a stimulus video, and also we can add more number of tasks. Not only 4 tasks, maybe we can add 8 tasks. Then we can see how we can classify it. We can get the high rate or not. Or we also in future work, we also can extend this when with the using the fusion of the different channel selection technique in order to improve the performance of the accuracy. And also this is the things that very famous now on how we can work based on the online signal processing of the proposed BCI. That means in a real time BCI. So this is the future work that we can tackle. And also because we also can come up with in the future work, we also try to come up with the algorithm that actually because this algorithm is depend on the person because the characteristic of the brain of the person is different. But some of the researchers also have begin to study on how we can come up with the general algorithm. That means for all subject have the same result, even though have the different characteristic of the brain. So lastly, just want to introduce our research group, Brain Machine Interface Research Group under the Faculty Technology Culture and Electric UNIMAP, and led by me. And also the member is Prof. Dr. Abdul Hamid Adam, Prof. Dr. Wan Khairul Nizam, Prof. Madya, Dr. Nur Arasmadi, Dr. Maniza, and Dr. Abdul Shafiq. And you also can go to our research group website there. There is a lot of information there. Maybe if you want to make a collaboration or want to make a postgraduate study on this area, so you can go into the website. I think that's all on my sharing on brain machine interface. Uh, Thank you very much.
Okay, thank you, Dr. Muhammad Shohanas, for the explanation on brain-machine interface and sharing his project with us regarding the classification of motor imagery based on EEG signals. So, Dr. Shohanas, Muhammad Shohanas, we have one or two questions here. Okay, so the first question is, how do you ensure that the sample, your sample, experiment samples, imagine the right motor imaginary? Because brain can play a lot of tricks, right?
Okay. Actually, it's based on the task that we have asked the subject. So that means we validate it by using the machine learning algorithm. So if the accuracy is high, so we say that we can differentiate the task accordingly. So if we see that the 90% above, then let's say we can differentiate it accordingly lah.
Also, based on the percentage of the accuracies, so you determine that the sample imagine accurate motor imaginary.
Yes,
I
because
mean, correct motor action. Yeah.
yes, because we just ask the person or the subject only to imagine this four tasks. So that's why in future
Mhm.
work we can add more tasks and see how is it.
Okay. One more question, Dr. Shonas. How accurate is the non-invasive compared to the invasive?
Of course, the invasive is more accurate. If we can see in Pittsburgh University have done invasive method. He implant the electrode on the cerebral palsy patient, and the cerebral can control the prosthetic arm. But uh, even though the invasive is more accurate, but it is more high risk because we need to make an operation on our head in order to implant the electrode. So that's why we are more into the non-invasive. So now the researcher want to come up with more accurate method on non-invasive. So it's more less risk compared to the invasive method.
Okay, thank you very much, Dr. Shonas. I don't think there's no more question in the comment. Okay, so thank you. Maybe after this, Masa also has their we our. I mean, we have also student that has the what we call I mean major towards the medical. Okay, so if we have time and if we have plan, you can plan something on doing. I mean collaboration with your group, your BMI group, inshallah. Terima kasih.
That's no problem. You can contact and you can go to our website and see and can
Okay,
contact each
thank
other.
you. So I
Thank you
think
very much.
that's all for today. Thank you very much, Dr. Muhammad Shwanas. Okay.